finally it let me in.
All right, let's get everybody loaded in here. Looks like we're still waiting on a couple more.
Miss Jennifer, did you get my email?
I did, and I just sent them to you.
Okay, I'll go print them off real quick.
That's fine. I sent you 21 through 25, and would you rather them be in color or black and white, or do you care?
It doesn't matter.
Okay, I think I sent them. I used a different app scanner this time, so I think they may be in color, but I can change them to black and white if you need me to.
Okay, no, that's good.
Okay. All righty, let's see, make sure we're missing one. Who are we missing?
I just got really mad at myself because I remember when you said 3 4 3 4 3 4. I apparently I missed one of the 3 4s and I did another 3 4 and I did a 4. I mean I did a 3.
I'm sorry, do what?
When we were doing the assignments, I'm going back and looking over them to make sure I did all of them.
Oh, okay.
I did the stuff in the extra credit, but I missed one of the 3 and 4 on the first lesson.
Oh, okay.
I think my pages must have been stuck together and I forgot.
I guess it's Mark that we're waiting, that isn't logged in. It looks like I've got everybody else, so hopefully he'll log in just a minute. All righty, so let's go ahead and get started and kind of take a look. It seems like I haven't seen y'all in forever. Hope y'all enjoyed y'all's Monday off, and then we'll go ahead and get started on everything. So the first thing that we'll need to do is to check our homework. So when we were last together, we worked with adding, subtracting, multiplying, and dividing polynomials. So let's go ahead and take a look at our homework and see. Remember that I need homework and test corrections. If you haven't sent me any test corrections yet, go ahead and make sure to get those to me today, so I can get those finished up and get your grades entered. Remember, if I don't get test corrections from you, I'll just enter your grade as is from when I sent it to you originally, okay? I think we already talked about with our uploading homework that if you can put it all in one document, that's great. Just try to make sure to label everything, make sure, you know, I can see your page number on it, and go ahead and start sending me the whole pages instead of just sending parts of pages. It'll be easier for me to be able to put together, because when I've got multiple pages coming in and it's just sections, I'm having to figure out what page is what and all that good stuff. And then, so anyway, that would be great. All right, so on the 3rd, when we last met, the first homework we need to look at was page 28, activities 4, that went with lesson 13. So go ahead and turn to that if you're not there already.
What page?
Lesson page 28, it looks like. So it's from lesson 13, page 28. We had activities 3 and 4. Okay. Clean my glasses off. So this was let's see. Activities 3 was writing the problem vertically and subtracting. Okay, remember we talked about subtraction. We talked about how it's easier to do adding the opposite. So when you change your subtraction sign or your minus sign to addition, you want to make sure that you change the sign of all of the terms that follow. Okay, so everything that comes afterward. So what I'm going to do is I'll go ahead and read the problem and tell you if you changed it to adding the opposite, what it would become, and then we'll give the answer. So on activities 3, the first one, what we'll do is we'll go top to bottom. I'll read the top one, the middle one, and then the bottom, and then we'll shift over to the next column. All right, so the first one started out as 4x squared plus 6x plus 5 minus x squared plus 3x plus 4. So when you wrote it vertically and changed to adding the opposite, it would become 4x squared plus 6x plus 5. That all stays the same. But then you would write plus negative x squared minus 3x minus 4. Then your answer would be 3x squared plus 3x plus 1. Questions on that? Any questions? What I'll do is I'll go ahead and share my screen in case we need to work any of these.
Which one were we on?
Hold on just a minute. Now I'll pull it up on the screen so you can see, so we can make sure we're on the, let's see. We've got that there, notability.
I have coronavirus.
Go back. Algebra 1. Text pages. Nope, that's not going to be right because that was the first set. I think I need that set. All righty.
That's page 4. That's the fun.
Okay. Here we are. So on the very first one, your answer should be 3x squared plus 3x plus 1. Okay, this is on page 28, activities 3. Is everybody, are we all together now?
Yes.
Page
Okay.
28's addition.
Did I write down the wrong page?
And add.
Sorry, my teacher book does not have page numbers in it that correspond with the textbook, so let me look at the book. So
You're on page 30.
So page 28 went along with
Adding.
That is on page 30.
so that's lesson 12. I'm sorry, I wrote on my page okay, so we need to back up. There we are. Ta-da. Okay. So lesson 12 is actually where we need to be. Lesson 12, page 28. Now are we all together?
Yes, ma'am.
All righty, let's try this again. Okay, so this first one is going to be 4x squared plus 9x plus 5. The one underneath that will be 9x squared plus 2x plus 7. Underneath that will be x squared minus x minus 1. Any questions on those? Any of those you'd like me to work? Okay, let's move over to the other column. The top one will be 10x squared plus 9x plus 6. Underneath that will be 8x squared minus x plus 1. And then the last one will be 3x squared minus 3x minus 3. Any questions on any of those? Any of those that you missed that you want me to help you understand why you missed it?
Did you do the third one out of the first column?
First column, the very last one at the bottom. Is that what you're asking?
Yes, ma'am.
Okay. So on this one, the first thing we want to do is go ahead and line it up vertically to where we have 3x squared minus 4x plus 3 plus negative 2x squared plus 3x minus 4. Once they're all lined up, I'm going to look at my first column, which is 3x squared plus a negative 2x. Okay, so 3 plus a negative 2 is a positive 1. I don't have to write that one. I can if I want to, but I don't have to. And so that one's going to be just x squared. Okay, then my next one, I have negative 4x plus 3x. So negative 4x plus 3x. So a negative 4 plus 3 is going to give me a positive 1. So that would just be plus, I'm sorry, negative 4 is the larger, so it's going to be minus x. Then the last one, I've got 3 plus a negative 4. Again, I'm going to take the sign of the larger, which is a negative, and the difference is 1. Okay, does that help?
Yes, ma'am.
Awesome. Okay, Mark, for you just tuning in, we're checking homework. So this is on page 28, activities 3. We had just started with this, so you can go ahead and pull that up. All right, so then in activities 4, negative 62 plus a positive 23 will be negative 39. Negative 46 minus a negative 91. Again, this is where we want to go ahead and change to adding the opposite. So now I have negative 46 plus a positive 91. So that will be a positive 45. Positive 57 plus a positive 72 is 129. Positive 103 minus a negative 25. Again, I want to change to adding the opposite. So now I have 103 plus 25. That's 128. Negative 58 plus a positive 79. I take the sign of my larger, which is positive, find the difference, which is 21. Negative 68 minus 92. I want to add the opposite. So now I have negative 68 plus a negative 92. So that will be a negative 160. Any questions in that left-hand column? Okay, let's move over to the right-hand column.
I have a question.
Okay, what you got?
Can you do the last one again?
Okay, so we have negative 68. We had to change from subtraction to addition. And because we did that, then we had to change the sign of 92. 92 started out positive, so when I change the sign of it, it becomes negative. So now I have negative 68 plus negative 92. Okay, so when I'm adding like signs, my sign stays the same. So I have a negative plus a negative, so I'm going to have a negative answer. And then I'm going to add 68 and 92. 68 plus 92 is going to be 160. Millie, hush. Come here. Come here. You need to go outside? Okay. Any other questions on that column?
No, ma'am.
Okay. Let's go ahead and move on over to multiplication and division. All right, so the first one I have 14 times 5. They're both positive, so I'll have a positive answer of 70. Negative 16 times negative 7. Again, when I multiply two negatives, my answer will be positive, and it's going to be positive 112. The next one, I'm multiplying three numbers, and I have one negative. When I have an odd number of negatives, my answer will be negative. So then 11 times 5 is 55, and 55 times 2 is 110. The next one, I have three negatives. So again, it's an odd number of negatives, so I'll have a negative answer. And 12 times 4 is 48, and 48 times 9 is 432. So negative 432. The next one, negative 75 divided by 15. I have a negative divided by a positive, so then I'm going to have a negative answer because I have an odd number of negatives. 75 divided by 15 is 5. And then negative 108 divided by negative 4. I have two negatives, so that gives me a positive solution. And 108 divided by 4 is 27. Any questions on the right-hand side? All righty, so now we will move on to page 30, where I tried to start with. All right, so we'll go through these. All right, the first one, we were supposed to write vertically and subtract. So the answer for the first one is 3x squared plus 3x plus 1. Underneath that, I'm going to have 5x squared plus 4x plus 4. And then I will have 5x squared minus 6x plus 2. Questions on the left-hand side? Any of those you'd like me to work? Okay, let's move on to the right-hand column. On the right-hand side, we would have 4x squared plus 6x plus 3. Underneath that, 6x squared plus x plus 1. Sorry, UPS man coming down the street. All right, and then the very last one is going to be 8x squared minus x. Any in the right-hand column you would like me to work? Any questions on those? All righty, let's go ahead and look down the page. We were solving and it says use the distributive property where appropriate. So I told you guys that when I use the distributive property, I like to draw my arrows. Okay, so you could either distribute first and then add, or you could add then multiply, but 4 times 25 is 100. 4 times 8 is 32, so your answer would be 132. On this one, 7 times 20 would be 140. 7 times 9 is 63, so when I add those together, I get 203. 13 times 1 is 13. 13 times 30 would be 390, so my total would be 403. 11 times 20 is 220. 11 times 8 is 88, so 220 plus 88 is 308. 14 times 10 is 140. 14 times 2 is 28, so that would be 168. Any questions about the first half?
I got most of the wrong, but I think it was because I didn't realize that parentheses were meant multiplication, so I had answers, but it was just adding them together. And
Okay.
so
Yeah, so the main thing to know is anytime I have a number right next to parentheses, that means I'm going to multiply. It's a symbol for multiplication, okay? So if you were supposed to add it, then it would look like 4 plus 25 plus 8. You would have that plus sign if you were going to add. But since the 4 is outside parentheses, that means I'm going to multiply, okay? So I'm glad you recognize that mistake. You know what to do to correct it. Good job.
Yeah, I got those wrong too. I added the stuff inside the parentheses, then multiplied.
Okay, but then you should have ended up with the same answer. So if I add, like on the first one, 25 plus 8 is going to be what, 33? And then 33 times 4, 3 times 4 is 12, carry my 1, 4 times 3 is 12 plus 1 is 132. So even if you added first and then multiplied, then you should have the same answer. So the only time it would be the wrong answer is if you did not add or multiply correctly. That's why I was saying for a lot of these, it's easier to distribute first and then add because you're not having to deal with as big of numbers. Same thing here. If I have 20 plus 9, that's going to be 29 times 7. 9 times 7, 63, carry my 6. 7 times 2 is 14. 14 plus 6 is 20. So you should end up with the same answers, even if you add, then multiply, okay? So look back at the ones that you missed and look to see, was it an addition error or was it a multiplication error? All right, so on this one, same thing. I could either start by distributing or I could add them together, then multiply. If I start by distributing, I'd end up with 8 times 25 is 200. 8 times 9 is 72, and 8 times 12 is 96, so your answer would be 368. Likewise, if you added 25, 9, and 12, and then multiplied by 8, you should still end up with 368. So any questions about that one? All right, now what we're going to do is go ahead and look at our order of operations problems. Okay, so parentheses, exponents, multiplication, division, addition, subtraction. Think in order of operations. So I have parentheses here, so that's where I'm going to start, is right here with my parentheses. So 11 minus 5 is 6 squared minus 15 divided by 3 minus 2 to the 4th power. I'm going to deal with my exponents, so I can do both of those in the same step. 6 squared is 36. Minus 15 divided by 3 minus 2 to the 4th is going to be 16 because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. I've cleared all my exponents, so I can see here that I'm going to divide. So I'm going to have 36 minus 3 minus 16. Because I have subtraction, I'm going to go ahead and do it in order from left to right. 36 minus 3 is 33 minus 16. 33 minus 16. Hold up. I messed up. I put 3 instead of 5. I said 15 divided by 3 is 3. It is 5. So that messes this number up. So that will be 31 minus 16. So your answer should be 15 on that one. Any questions on that one? Okay, let's look at the next one. All right, I have 2 sets of parentheses, so I can go ahead and do both of them in the same step. I'm doing 5 plus 3 and 13 minus 7 in the same step. So 5 plus 3 is 8. So I have 8 squared minus 4 cubed plus 2 times 13 minus 7 is 6 plus 18 to the 0 power. I'm going to do exponents first and go ahead and clear those. I can do all of those in one step. So I'm doing 8 squared, 4 cubed, and 18 to the 0 power. 8 squared is 8 times 8, which is 64, minus 4 cubed. 4 times 4 is 16. 16 times 3 is 64. Plus 2 times 6 plus 18 to the 0 power. Anything to the 0 power is 1. Okay. Now I have subtraction, addition, and multiplication. So I'm going to multiply. So I'm going to have 64 minus 64 plus 12 plus 1. Addition and subtraction in the same problem, so I'm working from left to right. 64 minus 64 is 0, plus 12 plus 1, and 12 plus 1 is 13. So your next one should be 13. Any questions on that one? All righty. 6 plus 9 divided by 3 minus 21 to the first minus 2 cubed. I don't have any parentheses. I have exponents, so that's where I'm going to start. So I'm going to have 6 plus 9 divided by 3 minus 21 to the first is just going to be 21 minus 2 cubed. 2 times 2 is 4 times 2 is 8. All right. Addition, division, subtraction, and subtraction. So I'm going to divide first. So I have 6 plus 9 divided by 3 is 3 minus 21 minus 8. I have addition and subtraction, so I'm going to work from left to right. 6 plus 3 is 9 minus 21 minus 8. 9 minus 21 is going to be a negative 12 minus 8. All right, negative 12 minus 8 is the same as negative 12 plus a negative 8. Changed from from subtraction to addition, and 8 becomes negative. So then I can see better that I have a negative plus a negative, which is going to be a larger negative. So it'll be negative 20. Any questions on that one? And then the last one, I don't know if your book had the parentheses in there. I think different print copies had them. So if it didn't have them, it probably made it a bit confusing. So go ahead and let's look at this one. It should have had parentheses because you can see where this little exponent is up here. They just didn't put the big parentheses in there for some reason. All right, so we're working inside the parentheses. So we're going to start right here with 27 divided by 3. And 27 divided by 3 is 9. So I have 9 squared times 3 to the negative second power. So I have to start thinking about, negative second power. What am I going to do with that? Plus 31 to the 0 power squared divided by. Now I can go ahead and take care of this parentheses. And 13 minus 8 is 5. Okay. Still working within those parentheses, I'm going to go ahead and deal with my exponents. So 9 squared is 81 times 3 to the negative second power. Remember, this is where I'm going to take my reciprocal, make my exponent positive, and it goes with the 3, plus 31 to the 0 power is going to be 1 squared divided by 5. So now I've got to take care of this in the middle. So I've got 81 times 1 over 9 plus 1 squared divided by 5. I'm going to start working this way. 81 times 1 over 9. So let's look at that first. 81 times 1 over 9. That's going to be the same as when 81 over 1. And when we multiply numerator by numerator. So 81 times 1 is 81. Denominator by denominator, 1 times 9 is 9. So now I have 81 over 9, which is the same as 81 divided by 9. And what is 81 divided by 9? 9. So 81 times 1/9 is equal to 9 plus 1 divided by 5. 9 plus 1 is 10. 10 divided by 5 equals 2. Any questions on that? I know it probably made it a bit more challenging or confusing without having those parentheses on there. So that's why, what did I mess up on? What did I forget? That little guy right there said this is supposed to be squared. So let's fix that. So 9 plus 1 is 10 squared divided by 5. 10 squared is 100 And 100 divided by 5 is 20. I forgot to, my little exponent up there. Any questions about that? Is everybody feeling a little more comfortable with the order of operations, knowing what to do after everything, what order to do everything in? It just takes a little bit of time and patience. It's not something you can really rush through. That's where your mistakes come in. All righty, so then we moved on to our next page, which is page 32. We had activities 3, and we were either adding or subtracting. They went ahead and had everything lined up for us, but you can see our top half is addition and the bottom half is subtraction. So I'm hoping that you went ahead and changed these to adding the opposite. So we'll kind of walk through that a little bit to check them. All right, so what we'll do is we'll do the addition first, and then we'll do the adding the opposite. Okay, so the first one should be 14x squared plus 7x plus 6. Next to that should be 11x squared plus 2. Notice these two middle terms canceled each other out because negative 4x plus 4x, 4x plus a negative 4x is going to be 0. So that means that term just goes away, okay? You could have put a 0 in there. You could have had 11x squared plus 0 plus 2. That wouldn't be wrong, but you can just leave it out. The next one is going to be 11x squared minus 2x minus 4. Any questions on the first 3? All right, next row, we've got 12x squared plus 9x plus 10. Next to that will be 10x squared plus 2x plus 6. And then we have 9x squared plus 2x minus 2. Any questions on that row? All right, our last row of addition, 14x squared plus 3x plus 10, 12x squared minus 4x plus 8, and then 11x squared minus 4x minus 2. Any questions on that last row of addition? All right, now we're moving to subtraction. So this is where I have to take my opposite signs. After I change this to addition, my 6x squared becomes negative, 4x becomes negative, positive 4 becomes negative. So now I have 8x squared plus negative 6x squared, which will give me 2x squared. I have a positive 7x plus a negative 4x, which will give me a positive 3x. And positive 6 plus a negative 4 gives me a positive 2. Look at the next one. 8x squared minus 1x plus 6 minus 3x squared minus 3x. Again, I changed it from subtraction to addition. 3x squared becomes negative. Negative 3x becomes positive. So now I have 8x squared plus a negative 3x squared will give me 5x squared. Negative 1x plus a positive 3x gives me positive 2x. And then a positive 6 plus nothing just gives me positive 6. Any questions on that one? The last one on that row. Again, I'm going to add the opposite. So 10x squared plus negative 7x squared will give me 3x squared. Negative 2x plus a negative 5x is a negative 7x. Negative 3 plus a positive 6 is positive 3. Any questions on that one? Look at your middle term. Did you get negative 7x in that middle term? All right, next row. I need to change to adding the opposite. So add, that becomes negative, that becomes negative, that becomes negative. 8x squared plus negative 5x squared is going to be 3x squared. 8x plus negative 4x will be positive 4x. 5 plus a negative 4 is a positive 1. The next one, whoop. Come on. There we go. Again, change to adding the opposite. 2x squared was positive, so it became negative. 6x is negative, so it becomes positive. 3 is negative, so it becomes positive. 7x squared plus a negative 2x squared is 5x squared. Negative 5x plus a positive 6x is going to be a positive 1x, or you could just have positive x. Okay, I just wanted to put it just in case you needed to see it. And then 6 plus a positive 3 is positive 9. So you could have also had 5x squared plus x plus 9. Same answers. And then the last one in that row. All right. Add the opposite, opposite, opposite. 7x squared plus a negative 7x squared is 0. I don't have to put a 0 there. Okay, you could if you want to, but I'm just going to leave it empty. Then I have negative 2x plus a negative 4x is a negative 6x. Negative 3 plus a positive 5 is a positive 2. So your answer would just be negative 6x plus 2. Any questions in that row? The last row. 4x squared plus 5x plus 3 minus 5x squared plus 4x plus 1. I need to change to adding the opposite. So positive 5x squared becomes negative. Positive 4x becomes negative. Positive 1 becomes negative. 4x squared plus a negative 5x squared becomes negative 1x squared, or you could have just written negative x squared. Positive 5x plus a negative 4x is going to become a positive 1x, or you could have just put positive x. And then 3 plus a negative 1 is going to be a positive 2. So you may have written yours as negative x squared plus x plus 2. Next one. Again, I only have 2 terms in the bottom, so I know that I just treat the empty blank as a 0. Add the opposite, so I take the negative 2x squared and positive 3x. 4x squared plus a negative 2x squared is positive 2x squared. Negative 5x plus a positive 3x is, negative 2x. And 2 plus nothing is 2. And then the last one, I needed to change it to add a negative 3x, negative 6x, and positive 1. 5x squared plus negative 3x squared is a positive 2x squared. Negative 3x plus a negative 6x will be negative 9x. And negative 5 plus a positive 1 is negative 4. Any questions on those? I want you kind of assessing how you did on those. If you see that you have kind of a common error pattern, was it adding the opposite that messed you up? Was it forgetting to change to adding the opposite and trying just to subtract and then you made calculation errors? I want you to really focus on that, okay? Because as we continue working with positives and negatives is something that we're going to be doing through the year. So we've got to really make sure that we're proficient with those. Okay. All right. So then we went on to multiplying monomials in lesson 14. So we're going to keep on going. And did we have any homework from this page? Let's see. This was page 32. 2, activities 3. Is that right? All right, we had the whole page here.
I think this is page 34.
Duet, is this page 34?
So
Hold on a second. Let me get my book that. So the first one we did was page 28. And then we did page 30. This was 32. And then 34. Here we go. So page 34, we had all. All righty. I'll go through and just put the answers on there. If there's any that you need me to work, please let me know. All righty. So the first one is 14a squared plus 7a plus 6. What I'll do is I'm just going to go down the row for now. It'll be easier just to slide it down, and then we'll go back row by row. Then I have 13d squared plus 10d plus 11. Then I have 15g squared plus 3g plus 11. Then we have to add the opposite. 10j plus a negative 5j squared is 5j squared. 9j plus a negative 3j will be positive 6j, and 8 plus a negative 3 is a positive 5. Again, add the opposite of each of these. 6n minus 7n becomes negative n squared. 6n plus a negative 6n cancels, and that just goes away, or it would be 0. And then 3 plus a negative 6 is negative 3. So you end up with negative n squared minus 3. Again, we need to add the opposite. So all of those change signs, and x squared plus 6x, plus a negative 6x squared becomes negative 5x squared. 2x plus a negative 5x. 2x plus a negative 5x is going to be negative 3x, and nothing plus a negative 2 is negative 2. Any questions on the first column? All right, let's go to the middle. 11b squared plus b squared is going to be 12b squared. 6 plus 6b minus 5b will be a positive b, and 9 plus a negative 6 will be positive 3. 10e squared plus e squared is 11e squared. 7 plus a negative 4 is positive 3e, and 11 plus negative 4 is going to be a positive 7. 11h squared plus 2h squared is 13h squared. 4h plus a negative 7h is negative 3h, and 12 plus a negative 3 is going to be a positive 9. Now we're subtracting, so I have to add the opposite of everything. So 10k squared plus negative 2k squared is going to be 8k squared. Positive k plus a positive 4k is going to be plus 5k. And 4 plus a negative 1 is going to be plus 3. Again, I need to add the opposite of everything. 5p plus a negative 4p is going to be p squared. Negative 7p plus a positive 4p will be negative 3p. And positive 4 plus a positive 1 is positive 5. Add the opposite of everything. X squared plus a negative 3x squared is negative 2x squared. Negative 2x plus a positive 2x cancels and goes away, so that's a 0, and negative 1 minus nothing is negative 1. Any questions on that row? And then the last column. 6f squared plus 4f squared is 10f squared. Negative 6f plus a positive 5f is a negative f. 8 plus a negative 9 is negative 1. 7i squared plus 5i squared is 12i squared. Negative 5i plus positive 2i is negative 3i. And 4 plus a negative 9 is a negative 5. Oh, I skipped one at the top, sorry. 7c squared plus 5c squared is 12c squared. Negative 5 plus a positive 4 is going to be a negative c. And 6 plus a negative 9 will be negative 3. Scooting on down to my negative, or my subtraction. Add the opposite of each sign. So 8m squared plus a negative m squared is going to be negative m squared. Negative 4 plus a negative 7 will be negative 11m. Negative 5 plus a positive 4 will be negative 1. Add the opposite. 5r squared plus negative 9r squared will be negative 4r squared. Negative 4r plus a negative 6r is negative 10r. And negative 5 plus a positive 3 is a negative 2. Add the opposite. All right, 2x squared plus a negative 4x squared is negative 2x squared. Negative 6x plus a negative 7 is going to be negative 13x. Negative 8 plus a positive 2 will be negative 6. Any questions on the addition or subtraction? Pay close attention. If you miss them, I want you to practice correcting them, okay? The reason I gave you so much of these to work on for homework is because the only way to get proficient at it is to continue to practice. All right, then the bottom part of this, we talked about how when we multiply numbers and variables, when we multiply the coefficients, we just multiply the numbers together. So like in this first one, I would have 9 times 4 times 5. Okay, so 9 times 4 is 36, and then 36 times 5 is going to be 180. Then I have a cubed times a squared. Remember, when I have like variables, I add the exponents. So 3 plus 2 is 5. Then I have b squared, and b to the 4th, I add 2 and 4, and that's going to be 6. So your answer would be 180, a to the 5th, b to the 6th. Any questions on that? We'll look at the one below it. Again, I'm going to multiply my numbers. 9 times 7, 63. 63 times 2 is going to be 126. Now I have g squared and g cubed. So I have g, and I add my exponents. 2 plus 3 is 5. Then I have h cubed and h to the 5th, add my exponents, and that is an 8. So I have 126, g to the 5th, h to the 8th. Let's look at the next one. I see a negative exponent, so we're going to see what we need to do with that. I have 8 times 5 is 40, and 40 times 7 is 280. Then I have r and r squared. Remember, if I do not have an exponent, it is understood to be 1. So when I add those exponents, I'm going to have r cubed. Now here I have t to the negative 1 and t to the 3rd. When I add negative 1 plus 3, that equals 2. So I have t squared. 280 r cubed t squared. Any questions on that? All right, underneath that, 8 times 3 is 24, and 24 times 7 is 168. Now, alphabetical order, I'm going to start with my a to the 4th, add those exponents, so I have a to the 8th. Then I have z cubed, z squared, and z squared. So 3 plus 2 is 5, and 5 plus 2 is 7, so z to the 7th. Then the last one, I have 2 times 3 is 6. Now I have f. I've got to the 7th, -2, and 4. So I'm going to have 7 plus -2 plus 4. 7 plus -2 is going to be 5 plus 4 equals 9. So I have f to the 9th. Then I have g cubed, and then to the -4th. So 3 plus a -4 is -1. And you could just leave it like that. Okay, so 6f to the 9th, g to the -1st. Any questions in that first column? All right, let's go to the middle. 7 times 3 is 21, and 21 times 4 is going to give me 84. C to the 4th times C to the 3rd is C to the 7th. D to the 1st plus D to the 3rd will be D to the 4th. The next one, 2 times 7 is 14. So I have 14 J to the 3rd plus J, or plus the 2nd, so that's J to the 5th. K squared, and a 4 is a 6. 5 times 3 is 15. 15 times 4 is 60. V, I've got -3, +4, so that's going to be a +1. So you could either put a 1 there or leave it by itself without a 1, because I understand that exponent is 1. W, I have a -2 and a 5, gives me a +3. 5 times 4 is 20, and 20 times 6 is going to give me 120. B to the 4th, B to the 6th, B to the 5th. 4 plus 6 is 10, 10 plus 5 is 15. Then I have C cubed and C to the 4th, 3 plus 4 is 7. Now my last one, 7 times 4 is 28, and 28 times 6 is going to be 168. Start with my H's. I have cubed and to the 4th and -2nd. So 3 plus 4 is 7. 7 minus 2 is 5. Then I have J to the 2nd and the -5th. So 2 plus a -5 is going to be -3. Any questions on my middle column? And then the right-hand column, 6 times 4 is 24, and 24 times 5 is 120. E to the 5th and E to the 1st is going to be E to the 6th. F to the 4th and F squared will be F to the 6th. 4 times 2 is 8. 8 times 3 is 24. M to the 5th and the 4th is a 9. N to the 4th and the 6th is 10. I've got 2 times 3 is 6. X to the 4th and X to the -2nd is going to give me X squared. Then I have -y times a +y is going to give me a negative times a positive is a negative, and 3y cubed, or to the 3rd power plus 1. Hold up. I've messed that up. Hang on. Let me start that one over again, because I should have dealt with that negative in the very beginning. I wasn't paying attention to it. My understood coefficient of -y cubed is -1y cubed. So now I have 2 times -1 is -2, and -2 times 3 would be -6. So I should have dealt with that negative in the beginning. And then we have X to the 4th and -2nd is X squared, and then y cubed and y to the 1st is y to the 4th. Next one, 9 times 2 is 18. 18 times 8 is 144. D to the 5th, D cubed, So that's going to be 8, 9, 10, 11, D to the 11th. And then I have E squared, and E to the 1st will be E cubed. And then finally the last one, 13 times nothing is 13. K to the 5th, negative 2nd, negative 3rd. Now, 5 minus 2, or 5 plus a negative 2 is going to be 3, and 3 plus a negative 3 is going to give me 0. So you'd have k to the 0, and then m to the 7th minus 6 is going to give me 1. So I've got to clean that up. What is anything to the 0 power? 1. So this is going to be 13 times 1 is 13, and I wrote it backwards. 13m is going to be my final answer. So k to the 0 becomes a 1. M to the first is just m, so I end up with 13m. Any questions on either adding, subtracting, or multiplying polynomials? Is there any of these that you missed and you're not quite sure why? Chad?
Is it break time?
I don't know, is it? It's 11:19, it sure is. So go ahead and take a 5-minute break.
Oh, I was also going to say that I did get some of these wrong, but it was again with the parentheses problem that I just added them. But I went back over and fixed them.
Okay, perfect. Very good. Like I said, the whole key to it is checking your mistakes and knowing what you did wrong.
Oh,
Yeah, I got some wrong, but I'll correct them.
Okay, do you see what you missed or why you missed it as we went through them?
Yes, ma'am.
Awesome.
Miss Jennifer?
Yes.
Okay, so my mom sent you an email that I am going out of town next week.
Yes, and so I had responded and told her that I would send you that work today. And so let's see, so next week, let's see. We have just finished our polynomials. And so what we're going to be doing today is kind of reviewing all of this stuff. On Monday, actually probably what we'll do, yeah, on Monday we'll do a study guide. So today we're going to be going over properties of equality, and then we're going to be working on activity in lesson 17. So that means on Monday, we will be dealing with 18 and 19. We will probably be doing lessons 18, 19, and 20 for next week. So next week we'll have a test that I'll email to you. And then we'll have lessons, let me look at 18, 19, and 20.
Is it okay if I get that to you a little bit late?
Yeah, it'll be fine for you to get it to me when you get back.
Okay, thanks.
Yeah, so let's see. What I'll do is I'll put this, I'll type up an email real quick and send it to you with the assignment.
Okay, thank you.
You're welcome. righty. Is everybody back? Okay. All right, so remember that when we multiplied polynomials, we added them together, and when we divide them, we subtract them. Okay. All right, so what I'm going to be doing probably, I was trying to think. Okay. Well, all righty then. All right, so let's go ahead and turn to lesson 16. Lesson 16 is dealing with properties of equality.
Wow.
Do what? Who is that? I'm trying to get my screen to expand. Yesterday, I had a sweet little friend join my class that I don't even know where he came from. So I was trying to figure out if we had somebody jump in. All righty. So let's go ahead, and we are going to be lesson 16 on page 35. Dealing with
you sent me the lessons 21 through 25 like on the email, so I don't have like the last lesson I have is 15 and then it jumps to 20.
I'm sorry, I thought I had sent you 11 through 20 previously. Let me check real quick and I can send those to you. Did those come through?
I have to go check my computer, but I'll go look.
Okay, that should be 11 through 20. I think I had saved together. So check and see. So it would start. Because it's 20 pages worth, so you'll have to just print off the last half.
Okay, thank you.
You're welcome. Okay, so on page 35, lesson 16, we are dealing with properties of equality. So one of the things that we have to make sure to do when we are solving equations is we have to make sure that an equation stays balanced, okay? And so when I say that something is balanced, that means that it's equal on both sides. So think about if you've ever seen, like, it worked with a balanced scale ever in science. And so you know that if you add a little bit to one side, you also have to add a little bit to the other side to keep it in balance. Because if you add more or subtract more from one side, it's going to get heavier on one side and it's going to cause it to tilt. Okay. So we have to kind of do the same things with equations that, and again, I always, this is another thing that I will compare to, to siblings. If your mom came in and gave you $5, your sibling is going to want $5 as well. Or if she came in and gave your sibling $5, you want it too. And so to keep things even, to keep things fair, we, with our equations, we have to do the same thing. So on page 35, we're dealing with these different properties. So the first one is going to be the addition property of equality. And basically, this just says that you can add the same amount to both sides and keep it balanced. Okay, so if A is equal to B, then I can add C to both A and B, and it's still going to be equal to each other. The next one is the subtraction property of equality that says you can subtract the same value from both sides of an equation. So if I took away the same amount from both sides, it's still going to be equal. Multiplication property of equality tells me I can multiply both sides by the same amount and it will still say balanced. If it's equal in the beginning and I multiply both sides, it will stay equal. Division property tells me I can divide both sides by the same amount and it will stay equal. The distributive property tells me that multiplication and division can be distributed across values inside parentheses. So just like we talked about earlier, this is the one where I draw my arrows. Okay, so earlier we talked about when we had all numbers, that even if we had all numbers, we could just add what was in parentheses and multiply by what's on the outside. But when I have variables and I multiply, I can't multiply A times B and come up with a new something, okay? I just have it as AB. And when I multiply A times C, that becomes AC, okay? Now notice it says the distributive property also works in reverse. Whereas if I start out with AB plus AC, I look at what they both have in common, which is the letter A. So I can take out that letter A, I can divide it from AB and AC, and I end up with A times B plus C. So the distributive property can work in both directions. I can either multiply a number by each term in parentheses, or I can divide a number from each term and leave it as a product, okay? My next one is the transitive property. And if you, one day, I promise you're going to hear all of these again because I was just teaching these in geometry this week and this morning. The transitive property says that if A equals B and A also equals C, then B and C are equal to each other, okay? So basically, if A and B are equal, A and C are equal, then that means B also equals C. The substitution property tells me that if A and B are equal, then I can substitute A and B for each other. I could plug in B for A and A for B, all right? So substitution property tells me that I can go ahead and substitute those values for each other. So these properties are going to help us as we get ready to start solving equations, okay? So if you look on classwork 1, it says solve each algebraic equation. For each step, identify the property that was used. All right, so I will tell you that this is something, again, we just did in geometry. So this is something that, that eventually you'll be kind of looking back at this same stuff. So learning it now is going to help you not only for this year, but also for next year when you take geometry. All righty. So let's take a look at this first one. I have x plus 8 equals 13. Remember, my whole goal here is to solve for x, Okay, so when I'm trying to solve for a variable, I look at what operations are being used that include that variable. So if I notice here, I have x plus 8. I need x to be all by himself, so I need to move that 8. So I've got to think about what is the opposite operation of addition, and that's going to be subtraction. So I need to subtract 8 on this side to get x by himself. So that means that I've got to also subtract 8 from the right-hand side, because my properties of equality, the subtraction property of equality, tells me I'm going to have to subtract it from both sides to keep it equal. So here I'm using the subtraction property of equality. So now when I have x plus 8 minus 8, all I have left on the left-hand side is x, and then 13 minus 8 is 5. So I've been able to solve for x, and x is 5. Any questions on that?
Why isn't it addition property?
Because I had to subtract to move my value. Okay, so I'm looking at this step right here. I subtracted to be able to move this 8 away from x. Does that make sense? Okay, so I had to use the subtraction property of equality to move that 8. Now let's look at the next one. I have 2x plus 12 equals 26. Now, one of the things I want you to remember is that when I have multiple steps to solve for x, the way I can remember how to do this, okay? Remember we have PEMDAS, our order of operations. Okay, so basically when I'm trying to undo a problem, I'm going to look at my operations in my problem. And so if I knew what x was, if I knew what that number was, the order of operations tells me that the first thing I would do is multiply, then I would add. So to undo my problem, I have to use these operations in reverse order, and I have to use inverse operations, which is the opposite. So if I was going to solve this and I would multiply, then add, my reverse operations tells me I would subtract and then divide, okay? Because I have to flip-flop them and then use the reverse order. So this tells me my order that I'm going to solve this problem in. So the first thing I'm going to have to do is to subtract. I'm going to subtract what is being added in this problem here. 12 is being added, so that's what I'm going to do first, is to subtract 12. So I need to take away 12 from both sides using the subtraction property of equality. Okay, so now I have 2x plus 12 minus 12. These 12s cancel each other out because positive 12 minus 12 is 0. So I have 2x left on this side equals 26 minus 12 is going to be 14. Okay, we already did our subtraction, so now we're going to divide. I divide what is currently being multiplied in my problem. 2 is being multiplied by x, so that means I have to divide by 2 because I want x to be by himself. So I'm going to divide this side by 2 as well. This is using the division property of equality. So now 2 divided by 2 is 1. So x is left on this side, and 14 divided by 2 is 7. Any questions on how we did that? Remember, if I'm solving using order of operations, I use PEMDAS this way. When I'm trying to undo a problem, I'm going to use reverse PEMDAS. And so what I do is I look and say, what would I do to solve it if I knew it? And then I have to do the opposite inverse operations to undo it. So let's look at 6x minus 5 equals 49. If I knew what x was, I can see that I would multiply and then subtract. So that tells me that for this problem, I need to reverse that order and do opposite operations. So that means I'm going to need to add and then divide. So now I know what operations I'm going to use. So since my first thing I need to add what is currently being subtracted. Right now 5 is being subtracted, so I need to use the opposite and add. This is the addition property of equality. Okay, so now 6x minus 5 plus 5, those two cancel each other out, so all I have left on the left-hand side is 6x equals 49 plus 5 is going to give me 54. I already added, so now I need to divide. I'm going to divide by 6 because remember, I'm trying to isolate x. I need x to be by himself. So I divide both sides. This is using the division property of equality. Okay, 6 divided by 6 is 1, so those cancel out. So I have x on the left-hand side, and 54 divided by 6 is 9. So x equals 9. Any questions about that? All right, now we need to look at this problem. And I have a number outside of parentheses. So that tells me that I'm going to need to distribute before I can start moving anything from side to side. Okay, so my first step is to distribute this 2 to each term inside parentheses. So this is the distributive property. So 2 times x is 2x, and 2 times a positive 1 is a positive 2. So I have 2x plus 2 equals 22. Is everybody good with that? Any questions? All right. So now, Are there any questions?
Oh no, ma'am. I must have accidentally my mic. I must have accidentally turned on.
That's okay. All right. So we distributed.
Why is 2x on the other side?
Because we just distributed. So 2 times x is 2x. Notice here's our equal sign. Okay, so everything that's over here is going to be on the left-hand side. So when I multiply 2 times x, that's 2x, and 2 times 1 is 2. All of that is on the left-hand side of that equal sign. So it has to stay there for now until I start moving things. Okay, so we use the distributive property to do that first. So now I'm going to look at this, and I can see that if I was going to solve this, if I knew what x was, I would multiply, then add. So to undo it, I use inverse operations in reverse order. So that means I'm going to have to subtract first and then divide. So I'm going to subtract what is being added in the problem. 2 is being added, so that means I'm going to subtract it. This is the subtraction property of equality. All right. Those 2's are going to cancel. So I have 2x, equals 22 minus 2 is 20. Right now, I have 2 times x on the left-hand side, so to undo multiplication, I use division. So I'm going to divide by 2, but if I divide by 2 on the left, I have to divide by 2 on the right. So this is the division property of equality. All right, 2x divided by 2. My 2's cancel out. So I have x equals 20 divided by 2 is 10. Okay, so like I said, what I do is I look at my problem. If I knew what x was, I would go ahead and solve it. So what I do is I look at the operations I would use to solve it, and then I have to do the inverse operations in reverse order. So what I want you guys to do right now is go ahead and work on this first problem. 3x plus 5 equals 17. And it says to solve it, and for each step, identify the property of equality that was used. So go ahead and work on 3x plus 5 equals 17. I hope everybody's working on your problem.
I finished it.
Awesome.
Me too.
Perfect. All right, so let's take a look at this. If I knew what x was, order of operations tells me I would multiply, then add. So I've got to use inverse operations in reverse order. So that means the first thing I'm going to do is subtract, and then I'm going to divide. Is everybody feeling okay with figuring out what you have to do first? Does anybody have questions about that? Okay. So I know I'm going to subtract what is being added in the problem. I'm adding 5, so that means I need to subtract 5 first. That is the subtraction property. I'm just going to, so sub-prop of equality. I've just gone ahead and abbreviated. All right, so I'm subtracting 5 from each side. Those 5's cancel, so I'm left with 3x is equal to 17 minus 5 is going to give me 12. Now I have 3x equals 12. 3 is being multiplied by x, so that means I need to divide both sides by 3 to be able to isolate x by himself. So this is the division property of equality. So now 3 divided by 3 is 1, so that cancels there because 1 times x would be x. And 12 divided by 3 is 4. Did everybody get that x equals 4? Good. Go ahead and do the next one. 5x minus 5 equals 30. Also name the properties that you use. All right, so here I would multiply, then subtract. So using opposite inverse, I would add, then divide. I'm going to add what is being subtracted, so I add 5 to both sides. So 5x equals 35. Now I'm going to divide by 5, divide by 5. Those cancel, so x is equal to 7. So here I use my addition property. And then I use my division property. And then finally, let's go to the last one. All right, so on this one, the first thing I have to do is distribute my 3 to x plus 2. So I end up with 3x plus 6 equals 21. So that was my distributive property that we used there. Now I look at the problem and say, if I was going to perform the operations here, I would multiply, then add. So I need to do reverse inverse. So the inverse of addition is subtraction, inverse of multiplication is division. So I'm going to subtract 6 from both sides. That's my subtraction property of equality. So those cancel, and I have 3x is equal to 15. Then I divide 3 on both sides, and I get x equals 5 because I use the division property of equality. So x equals 5. Any questions on that?
I need your consent on a few items to
Any questions on those? All righty, now flip over to lesson 17 on page 37. This is when I have variables on both sides, okay? So it says when variables appear on both sides of the sign in the equation, use the properties of equality to isolate the variable on one side and the constant terms on the other, okay? So the first thing I want to do is I want to put all my variables on one side and my constants, or just my numbers, on the other. So it says generally the variables are moved to the left-hand side and the constant terms are moved to the right-hand side, although it's not mandatory, but it just, anytime you write your answer, you always want the variable to come first. So I typically go ahead and move my variable item first to the left-hand side. So when we look at this example here, you can see that I have 5x plus 8 on the left-hand side, and that equals 4x plus 13 on the right-hand side. So the first thing I want to do is I want to move that 4x from the right to the left. It is positive on the right-hand side. So that means the way I'm going to move it is to subtract it. Okay, because it is positive, to move it, I would subtract it. Okay. So now I'm going to end up with 5x plus 8 minus 4x on the left-hand side, and 4x plus 13 minus 4x on the right-hand side. So when I deal with those, 5x minus 4x leaves me x, and then I have 8 still on the left-hand side and 13 on the right. So now what I need to do is go ahead and move that 8. So I'm going to subtract 8 from each side, and I have x equals 5. Okay, so move your variables first. I prefer to move them to the left-hand side, and then move your constants to the right-hand side. Okay, so that's what we're going to do in our classwork. So the first thing I'm going to do, I've got 7x plus 12 equals 5x plus 26. 5x here is positive. So the way I'm going to move it is to subtract 5x from each side. Notice I go ahead and write it underneath the one that has the like term. So 7x minus 5x. This was the subtraction property of equality that I used. So 7x minus 5x is 2x. I still have plus 12 on the left-hand side. These cancel out. So all I have left on the right-hand side is plus 26. Or just 26. Now I need to move my constants to the right-hand side, and I've got a 12 on the left. So I need to subtract 12 from each side using, again, the subtraction property of equality. So my 12s are going to cancel here, and I have 2x is equal to 26 minus 12 is 14. I need x to be by himself, and right now he's being multiplied by 2, so I need to divide by 2, and x is equal to 7, and I found that by using the division property of equality. Any question on how we did that? The first thing we did was move the variable from the right to the left. Then we moved the constants from the left to the right. And then we just undid whatever was being done to x. So let's do the same thing with the next one. But notice here, I have a negative 2x. So to be able to move it, because it's negative, I'm going to add. So if I add 2x over there, I have to add 2x over here because of the addition property of equality. So 4x plus 2x is 6x minus 5 equals 49. I want to move my 5 over here to my right-hand side using the addition property of equality because it was being subtracted over here. Those will cancel. 6x equals 54. Now I have 6x equals 54. I need to solve for x. It is currently being multiplied by 6, so to undo it, I need to divide by 6, but I have to divide both sides because of the division property of equality. 6 divided by 6 is 1, so those cancel, and I have x is equal to 54 divided by 6 is 9. Okay? All righty, so let's go ahead and take a look at homework. Okay? We worked on lessons 16 and 17. So for lesson 16, I want you to go ahead and turn back to page, well, actually it's not back, it's just the opposite side. So we've got page 36. This is page 36. I want you to do activities 3. Then we have page 37. Activities 2, and then to help us prepare for our test that will be next week, page 38 all. We have about 5 minutes left in class, so what I want you to do is I want you to go ahead right now and start working on activities 2 on page 39. I'm sorry, not 39, 37. I want you to, huh?
It's due on Monday.
So what we're gonna do is, if you don't finish it all by Monday, I would definitely want you to, we'll go back and look at it, and if you don't finish anything, we'll kind of work on it Monday. I definitely want you to have page 38 done by Monday, because that is a review for our test. Okay? So I definitely want you to have page 38 done by Monday. If you don't quite finish up 37 and 36, then that'll be fine. I'll let those be due on Thursday. But I definitely want you to finish 38 by Monday, because that'll be the day that we're going over the study guide and getting ready for our test on polynomials. So I want to make sure that you are confident with those. Also, look at 38 for a minute. Look at your page 38. Do you remember when we talked the other day about these funky little check mark signs, or it kind of looks almost like a radical sign? Remember, that means division. Okay, for whatever reason, they used them, some division signs and some with that. If you see those little signs, that means division. So remember, when I divide my monomials, or when I'm dividing, I'm going to say 39 divided by 13 first, and that will be 3. And then I have a to the 5th divided by a squared. That means I'm going to do a to the 5th minus 2, and 5 minus 2 is going to be 3, so that's going to be a to the 3rd. So my answer here would be 3a to the 3rd. I'm going to divide my numbers, and then when I'm dividing my variables, I subtract them. Remember, with multiplication, I add them. But with division, I subtract them. Okay? Any questions before we get ready and go? Like I said, I
still kind of don't understand how to like do the problem, like find the algebraic equation. That's kind of hard.
So you're talking about what we just did?
Yes, ma'am.
You're talking about here?
Yes.
Okay, so what I want you to do
Yes,
is
ma'am. I don't understand how to get those problems.
Okay, so let's look at this. Remember, the first thing I said you want to do is you want your variables to move to the left-hand side. So what variable on this problem is on the right side of my equation?
X.
X. Is it positive or negative?
It's positive.
Okay, so the way I'm going to move it is to subtract it. Okay, so I want to subtract X from each side. That goes ahead and cancels that because X minus X is 0, right?
Mm-hmm.
Okay, so but if I subtract X on the right-hand side, I have to subtract it on the left-hand side. So 4X minus X is going to be what?
3X.
3X, good. So I have 3X, I still have plus 7 over there, equals, and on my right-hand side, I only have 19 left now. Okay? If I knew what X was, using the order of operations, I would multiply first, and then I would add. Are you good with that?
Mm-hmm. Yeah.
Okay, so that means to undo it, I'm going to go reverse order, inverse operations. So we said we would multiply, then add. Now I've got to reverse those and use the opposite operation. So that means the opposite of adding is subtracting, and the opposite of multiplication is division. So these are the operations I'm going to use to solve this problem. Okay, so the first thing I need to do is I'm going to need to subtract what is being added on the left-hand side. Well, 7 is what's being added. So I would subtract that first. Okay? A positive 7 minus 7 cancels out. 7 minus 7 is 0, so that goes away. So on the left-hand side, I'm left with 3X equals 19 minus 7 is 12. Are you good so far?
Yes.
Awesome. Okay, so we subtracted first. Now we know we have to divide. Well, what is being multiplied is what I'm going to have to divide. So 3 is being multiplied by x, so that means I'm going to divide by 3. But if I divide the left-hand side by 3, I have to divide the right-hand side by 3. 3 divided by 3 is 1, and 1 times x is x. So all I have left on the left-hand side is x. Now, 12 divided by 3 is 4. So I found that x is equal to 4. Okay.
And I know now I know how to do those. How do I do the ones with like the parentheses and stuff?
Okay. For those of you that are ready to go, if you want to hang on a few minutes and see those, we're going to back up to page 36. If you want to stay, if you want to hang around and go through these a little bit more, you're welcome to. But if you are already done and you're good with everything, you may go. All right.
Thank you, Miss Jennifer.
You're welcome. Thank you. Have
Bye.
a good weekend. Bye-bye. Bye-bye. Okay, so let's go ahead and take a look at these with parentheses. Remember, it's the distributive property that I use, okay? And so I have to, this is what we have to simplify it first. So that means my 3 on the outside, I have to multiply by everything on the inside. Millie. Sorry, mailman. Okay, so I have to multiply 3 times x and 3 times 2 because it is outside parentheses, and I have to distribute it to each term inside. Millie, hush. So 3 times x is 3x, and then 3 times 2 is 6. Because it is positive, I put my plus sign, and that would be 3x plus 6 equals 27. Are you good with that? Mm-hmm. Okay, so now I've just got to undo my problem. Okay, the order of operations tells me that if I knew what x was, if I had a number to plug in for x, I would multiply, then add. So I'll go ahead and put multiply, then add. So now to be able to solve for x, to undo my problem, reverse order, inverse operations. So what would I have to do first?
Divide and subtract.
Okay, we got to do
subtract
it.
and then divide.
Good. In the opposite order, subtract, then divide. So now I know what I'm going to do. What am I going to subtract on the left-hand side?
6.
Good, because it's being added, I'm going to subtract it. That also means I have to subtract on that side. So what's left on the left-hand side?
3x.
Very good. 3x is left because those 6's cancel each other out because 6 minus 6 is 0 equals, oh, I wrote 36, not 3x. Those cancel. Let me just get my eraser. There we go. So 3x is over here, and 27 minus 6 is 21. So we subtracted. Now what am I going to need to do?
Divide.
Divide. What am I going to divide by?
3.
3. Very good. 3 is being multiplied, so I'm going to divide by 3. But if I divide on the left-hand side, I have to divide on the right-hand side. So those are going to cancel. So I'm left with x on the left-hand side, and 21 divided by 3 is 7. Okay?
And how do I do the more longer ones?
Okay.
Like
the one below it?
The number 2 one. The number 2. Like
This
the
one?
last. Yes.
Okay, perfect. Let's do it. Okay, so the first thing I do is distribute. Okay, like I said, I always draw my little arrows so I don't forget. It's just a habit I've gotten into so I don't forget, and so I'm a very visual person. I need to be able to see things. Okay, so that helps me to see that I'm multiplying 2 times x and 2 times 1. So 2 times x is what?
2x.
Good. And 2 times 1 is?
2.
2. Since it's positive, I have plus 2 right there. Okay. What else do I have left on the left-hand side?
5.
I have minus 5, so I can't just leave them out. I've got to put it there, okay? Equals 31. So now what I'm going to have to do is I'm going to have to combine like terms. On the left-hand side, what are my like terms?
2,
2 and
5.
good. So I've got a positive 2 and a negative 5. I have 2 minus 5. Okay, so those are considered like terms because they're both numbers. Okay, so 2x, what is a positive 2 minus 5?
Negative 3.
Negative 3, so that's why I'm going to write minus 3 equals 31. So now I look at my problem and say, okay, to be able to solve this according to the order of operations, if I was going to solve it, what would I do first?
You gotta add 3 to negative 3 and 31.
Okay, so the first thing I've got to do is I'm going to add 3 to both sides because I'm going to use the reverse order inverse operation. So now those cancel. So I have 2x equals 31 plus 3 is 34. Now what am I going to do?
Divide.
By
2.
2. Very good. Divide both sides by 2. Those 2's cancel. So I have x, 34 divided by 2 is 17. And there's your answer. Does that help?
Yes.
Okay. Just remember, take it slow. Write it out step by step. Okay. If you have questions this week or next week, feel free to text me pictures and say, hey, I'm stuck, or, is there a chance of calling? If we need to set up a one-on-one Zoom to work through it, if you get confused and don't know what to do, that is just fine, okay? So anytime that you're not understanding something, be sure to let me know, and we'll set up a time to work, okay?
Okay, thank you.
You're so welcome. Where are y'all going next week?
The beach.
Oh, it'll be so wonderful. I hope you have
Yeah.
a great time. So like I said, I'll have the videos posted so you can either try to work through the lessons on your own or you can try to watch the videos, whatever you rather do. But definitely if you have questions, let me know. Okay?
Okay.
All right.
Thanks.
Good job. See you
Bye.
next week or talk to you sometime. Okay?
Bye.
Bye-bye.